All right, let's dive right in. We're looking at what seems like a handful of totally separate projects, but stick with me because they tell a really fascinating story about a completely different way to think about artificial intelligence.
So first up, we've got this, a public GitHub page for a custom piece of hardware, a neural processing unit, or NPU, that they're calling Ariel. Then you have this, the Arc Lake Chemistry Lab. I mean, look at that interface. It's a seriously complex and detailed virtual world, obviously built for some heavy-duty molecular simulation by a company called Radical Deepscale.
And to top it off, there is a super dense technical paper from another group, Dart Meadow, that breaks down the exact properties of a new hypersonic alloy.
So you've got a custom chip, a virtual chemistry lab, and a space-age metal. These things feel like they're from completely different universes. So what's the deal? What's the thread that pulls them all together? Well, the answer is a pretty radical new way of looking at AI. Everything kicks off with the core idea behind the AI itself. It's a system with this really cool, kind of poetic name, the Lead Edge Ash Tree Reflex, or LEATR for short. Now get this, the core principle here is completely different from most AIs we talk about. Usually, an AI learns by trial and error, right? It loops over and over again, correcting mistakes. LEATR is designed as a reflexive system. The whole point is to avoid getting stuck in those error loops. Instead, it's built to just reflect directly towards a solution. And the engine that makes this happen is something called the Buoyancy Reflex Pendulum node. That's a mouthful, I know, but think of it as the AI's cognitive core. It's this fundamental process, this shell parameter that guides how it thinks, moving from formation of an idea to the reflex and then straight to performance. And this is where it gets really brilliant. Its entire thinking process is structured around an order of natural tools. And this is so cool because it means the AI's logic isn't just based on abstract ones and zeros. It's based on foundational concepts of doing things. A maze is about navigation, a hammer is about construction, scissors are for division. It's a fundamental toolbox of creative actions that lets the AI build and solve in a way that goes way beyond simple pattern matching.
So, if you have an AI that's basically a master builder at its core, what's the one thing it needs? It needs a workshop, right? A place where it can actually use those tools and get to work. And that workshop is the Arc Lake Chemistry Lab. You gotta understand, this isn't just some off-the-shelf simulation software. It's a virtual sandbox, custom-built for the Ash Tree Reflex AI to go wild, to experiment, design, and create things from the ground up.
I mean, you can see right in the interface how powerful it is. The AI can get in there and tweak molecular structures, control these complex physics simulations with things like the arc edge factor, and run all kinds of high-level math. This is its digital playground.
And that brings us to the most important difference here. A traditional AI is incredible at looking at all the data that already exists in the world and finding patterns. This system is built for digital invention. It learns by designing and simulating things that have never, ever existed before.
So this is where the rubber really meets the road. What actually happens when you unleash an AI like this on a tough, real-world engineering problem?
Well, you get something like this, the Hercules alloy. The documents give us the exact recipe. This is a material that was almost certainly designed and battle-tested inside a virtual lab, like ArcLake, long before anyone tried to make it in the real world. And the whole point is to engineer materials for the most insane applications you can think of. Take the Dart Hypersonic Edge alloy. It's being designed with a very specific checklist of properties to survive the unbelievable heat and stress of hypersonic flight. Okay, so let's zoom out. We've seen the AI brain, we've seen the virtual workshop, and we've seen the physical product. Let's connect all these dots and look at the whole integrated vision. So you've got two key companies making this whole thing tick. You can think of Radical Deepscale as the architects. They're building the brilliant AI mind and its digital workshop. Then you got Dart Meadow. They're like the master engineers, taking those digital blueprints and figuring out how to actually forge them into real-world solutions for things like aerospace. But here's the big question. How does a person, a human, actually plug into this whole creative ecosystem? That is the final and maybe the coolest piece of the puzzle. And the answer is Dart Dovetail. We're talking about an augmented reality interface. The idea is you put on a pair of AR glasses and you can see, control, and collaborate with the AI's work directly. You could visualize these molecular designs floating in the room with you and interact with the physics simulations in real time. And that right there connects everything into one beautiful, seamless workflow. It all starts with a creative spark from the Ash Tree Reflex AI. That AI gets its hands dirty inside the Arc Lake virtual lab. The output is a blueprint for a real-world product, like a crazy new alloy. And the whole time, a human collaborator is steering the ship through the Dart Dovetail AR interface. It really leaves you with a pretty wild thought, doesn't it? We spend so much time talking about AIs that can analyze data or write an email, but this is a system designed from the ground up, not just for analysis, but for pure, fundamental creation. It makes you wonder what's possible when our AIs stop just answering our questions and start building our future, literally from the atom up.